Hello everyone, today in this video we are going to talk about gravitational force. So after this video you should be able to define gravitational force, explain the properties of gravitational force and calculate the gravitational force between two objects. So gravitational force is the force of attraction between two objects, and this gravitational force is due to the mass of an object. And for the gravitational force to exist we should have two masses, otherwise the gravitational force will not act. And the gravitational force of the earth is called gravity. So this is the special name given to the gravitational force of the earth. So now these are the properties of gravitational force. It is universal, that means gravitational force attracts the object throughout the universe. It is attractive, it is always attractive. The gravitational force cannot repel the object. So it is a central force, meaning the force acts along the line joining the center of the two object. And it is conservative force, and conservative force means work done by the gravitational force does not depend on the path. It is a long range force, that means the gravitational force can pull the object which is far away from its source. And it is the weakest force in nature. So electrostatic force, nuclear force are stronger than this gravitational force. And weight of an object is the measure of gravitational force on the earth. So when I say my weight is 5 Newton, that time I am saying the gravitational force on me due to the earth is 5 Newton. That is, my weight is 5 Newton. Okay, now this is the Newton's universal law of gravitation. So the Newton's gravitational law says that the gravitational force between two masses m1 and m2 is directly proportional to the product of two masses, F proportional m1 into m2, and this force is inversely proportional to the square of the distance. So F proportional to 1 by r square. So we can write F1 proportional to m1 into m2 by r square. And if you remove this proportionality sign, you will get equal to sign, and we have to multiply this side with a constant, and this constant is called universal gravitational constant. Now the unit of g. So to find the unit of g, I'll write the expression and I'll take g this side. That means g is equal to fr square by m1 into m2. So now unit of g will be the unit of this side. So for force I'll write Newton, for distance square I'll write meter square, and for m1 and m2 kg and kg, that is kg square. So unit is Newton meter square kg minus 2, and in CGS unit it is dyne centimeter square gram inverse square. And the value of g is 6.67 into 10 to the power minus 11 Newton meter square kg square inverse, and the value of g is found out by Henry Cavendish, and dimension of g is m1 L3 t minus 2. So we can get this using this formula. Now let's define what is g. So we'll start with the expression. If we put m1 is equal to 1 kg, m2 is equal to 1 kg, and r is equal to 1 meter, then we'll get F is equal to g 1 into 1 by 1 square. So we'll get F is equal to g. So universal constant is equal to the force when we keep two objects of mass 1 kg each at the distance of 1 meter. So we define it like this. The universal gravitational constant is the force of attraction between two masses of 1 kg each kept at a distance of 1 meter. So out here you can see 1 kg and 1 kg, and distance is 1 meter. So force between them is equal to g. In our previous formula we did not have direction with the force. It was F is equal to g m1 m2 by r square. So there was no direction. In vector form we need the direction. So now in this figure you can see we have two masses m1 and m2, and force on mass 1 due to mass 2 is along this direction, because m2 will pull m1 this side, and similarly m1 will try to pull m2 this side. So force on 2 due to 1 will be in this direction, and the distance between them is r, and this is the unit vector going from mass 1 to mass 2, and this is the unit vector going from mass 2 to mass 1. Now in the figure you can see F12 is force on mass 1 due to mass 2, and this is towards the right, so this is pulling this side, and F21 is force on this due to this, so this will pull this side because the gravitational force is always attractive. And R12 and R21 is the unit vector, that's why I am writing R cap. You can see this vector and this vector, they are opposite to each other, and they are unit vector, means their value is 1, so they are having value 1 but their directions are opposite, so I can write they are equal and opposite. Equal and opposite, I have to put 1 minus sign. So according to universal law of gravitation, we know the formula F is equal to G m1 m2 by r square. Now we have to give the direction also. Now the direction of force on 1 due to 2 is from left to right, that means it is along r12, so I can give the direction r12, and I am writing it to be negative because the force is attractive force, so for attractive force we write negative. Now similarly F21 is going towards r, is along r21, so I can write F21 is, this is the magnitude and this is the direction, so negative sign indicates that forces are attractive. Now I am starting with F12, that is minus G m1 m2 by r square into r12, but we know r12 is equal to minus r21, so instead of r12 I can put minus r21. Now I'll take this minus out. Now I'll see this minus G m1 m2 by r square r21, so this is F21. So if you put the value of this as F21, you will get F12 is minus of F21. So this equation is saying two forces F12 and F21 are equal and opposite, that means they follow Newton's third law. Forces are equal and opposite, that means this object will try to pull this and this object will also try to pull this, and see 2 Newton and 2 Newton, so this object is pulling this with 2 Newton and this object is pulling this with 2 Newton. And now the next point, as R12 is equal to minus R21, the forces are central force, that means they are acting along the line joining center of two masses. So this expression says the universal law follows Newton's third law, and this expression is saying the gravitational force is the central force because they act along the line joining centers of two masses. So these two lines are the importance of universal law in vector form. So if the question comes, what is the importance of gravitational law in vector form, that time you have to say that the vector form of gravitational law says that the gravitational forces follow Newton's third law, and it also proves that the gravitational forces are central force. So you have to write this line. And if the question comes, write the universal gravitational law in vector form, that time you have to write this formula with the direction. So previously in the scalar form we just write F12 is equal to G m1 m2 by r square, but in vector form we have to have the direction also. So this time we'll write F12 is equal to minus G m1 m2 by r square and r12 cap. So this is the direction and this is the magnitude. Now this is a vector. So using Newton's law of gravitation we can calculate the force between two masses. But what if we have more than two masses? So to calculate the forces between more than two masses we can use superposition theorem, and it says that the total gravitational force on an object due to the number of masses is vector sum of gravitational forces exerted by all the masses. That means suppose I have one mass and on that mass other masses are exerting the force. Suppose m1 is pulling it with force 1, suppose m2 is pulling it with force 2, suppose mass 3 is pulling it with m3 and so on. So total force will be vector sum of all the forces. That means we have to add all the forces and we'll get the final force. So this is superposition theorem. Now we will calculate the force between multiple objects. So in this question there are three masses at the vertices of a triangle and masses are m, and m, and at the center I'm keeping the mass 2m and I have to find what is the total force on this 2m. And in second case, if you change this m to 2m, then what will be the force on this one? Okay, so first thing, as the distance of centroid from the vertices are equal, so I can write GA is equal to GB is equal to GC is equal to R, and the force between this m and this 2m, this m and this 2m, and this m and this 2m are equal because masses are also same and distances are also same. So FA is equal to FB is equal to FC is equal to G m, and second mass is 2m by r square. So this is Newton's law. So I'll get G 2m square by r square, and I'll denote this by F. Now I have to add all these three forces. So we cannot add it directly, we have to add it using vectors. So to find the resultant of two vector, we have this formula. So I'm adding FA and FB first. So to add this, we use this formula. So FAB is equal to FA square plus FB square plus 2FAFB and the angle between these two vectors. So let's find the angle between these two vectors. So this whole angle is 360 degree and this is divided into three equal parts. So each angle is 360 divided by 3, that is 120. So theta is 120. Now I'll put, instead of FA and FB, I'll put F. So FAB is F square plus F square. I'm writing from here, and plus 2F into F cos 120 degree, and the value of cos 120 is minus half. So I'm adding F square plus F square, that is 2F square, plus, now this is minus half, so this 2 and this 2 will get cancelled and this minus will come out. So I'll get FAB is equal to root over 2F square minus F square. So you will get FAB is equal to F square, that is F. So total force due to these two forces is F. Now by symmetry, now I say by symmetry FAB acts along the line opposite to FC, because I'm adding these two force, so I'll get the resultant which is opposite to FC. So now I have to add this resultant and this, so this will be the final answer. So now you can see, as FC is equal to FAB, so FAB is also F and FC is also F. So I can write FC is equal to FAB is equal to F. So they are equal and opposite. So the resultant force is 0. So if you add two equal and opposite, you will get 0. So total force on this mass due to this masses M and M will be 0. So there will be no force if all the forces are equal. Now we'll do the second part, that is what is the mass at point A is doubled, that means I'm making it 2m. So now when mass at A is doubled, so that time you can write FB and FC are equal. So I have not changed the masses at B and C, so this will remain same, that will be F, and FA now we have 2m. So 2m, that is 4m square. So I can write 2g 2m square by r square. So this will be 2 into F. So out here force is only F, and out here we have 2F. So this is G out here. So now let's find the resultant of B and C. Now we will calculate the resultant due to B and C. So we'll use the same formula. This is the formula to add the resultant of two vector. So FBC is equal to FB square plus FC square plus 2FB FC cos 120 degree. Angle between them is 120 degree. So similarly, the way we have done the previous question, we will get this to be F. If you put this as F and this as minus half, you will get FBC is F. Now this is coming down. The resultant of this two is coming down by symmetry. Now FBC. Now this FBC and FA are directed opposite to each other. So angle between them is 180 degrees. So I can directly write resultant force is, now I am finding the resultant of this two. So FABC is equal to FBC square plus FA square plus 2 FBC FA cos 180 degree. So cos 180 degree is minus half. So I'll put the value. So FBC is only F and FA is 2F. So I'll put 2F square. So you will get F square plus 4F square. Out here you will get minus 4F square. So this is positive and this is negative. I can cancel them. So you are left with FABC is equal to root over F square. So this will be F and the value is G 2m square by R square and it is towards the A. So the total force will be towards the A. So because we have 2m out here, so total force will be towards A and the magnitude will be G 2m square by R square. And if you don't want to do this second calculation, we have a shortcut. So let's see what is the shortcut. So we already know FBC is in downward direction and FA is in upward direction. So value of FA is 2F and value of FBC is F. As you can see, FA is in upward direction and FBC is in downward direction, and this is more, this is less. So we can just subtract this two to get the final answer. So we can say as FBC and FA are along opposite direction, their resultant is given by FABC is equal to FA minus FBC. Now FA is 2F and FBC is F, so you can write FABC is equal to F only, and the value of F is G 2m square by R square. So this is the final answer. So just to skip this part, you can write this orange part. So this is the end of the video. Please don't forget to like the video and subscribe the channel. Thank you.